All right, welcome to page 35 of this week, the second page of notes. You're going to like today. It's way easier than what we just got through on page 34. There's zero examples other than things that I might just kind of throw off on the side just to help us out in understanding what I'm talking about. So let's jump right into it. Today's goal is talking about identifying types of polar graphs, being able to look at equations and recognize it. Just like if you looked at the equation y equals mx plus b, you know it's a line. If you looked at x squared plus 3x plus 2, you know it's a parabola. Right, we know those things from practice. Same thing's going to happen here. We can look at these equations and we can say, this is going to be this type of graph. It's going to be a three-petal rose. It's going to be a limison. It's going to be a four-petal rose. Whatever it is, you're going to look at them and be able to say, this is what's going to happen. And then it makes graphing them a little bit less stressful because you know what to expect your graph to look like. So it is very beneficial to understand these. So the first one is circles and lemniscates. Lemniscates. I'm not sure if I'm saying that right. Lemniscates. So the way we recognize these is the first one is your circles. If you just have r is equal to a number cosine of theta or a number sine of theta, you know you're going to get a circle. Specifically, that number in front that we call a represents the diameter of the circle. So if you had that r is equal to 5 cosine of theta, well, we know that we're going to get a circle that goes out to 5 right there on that. Similarly, sine would be a circle that goes up. Where if this number also is negative, it causes it to be on this side. And if it was a sine, it would cause the negative to go down on that side. If you were to change it slightly, if you were to square r and make it r squared, and then have the a squared also squared, the a also squared, but this time instead of being a sine of theta or cosine of theta, it's sine of cosine of 2 theta, you get what's called a lemniscate, which kind of looks like an infinity sign. And you can see right here, for sine, it's going to cause it to go at a diagonal, right? And the a value is going to be the length of, if you draw this infinity sign, the a value is going to be this length right here. A little bit harder to check. The cosine version is easier because you get this actual infinity sign, and the a value is a nice horizontal line, so you could easily count that. For the sines, you actually would have to do a distance formula to figure out what that's going to be, so it's a little bit tougher. Our second type that we're going to look at is called limisons, which are a little bit harder to do because they take an extra step. You're going to notice a limison, and you see that little C. There's a little mark underneath it. I didn't do it in these bottom notes, but I probably should have. It's like a little C with a little kind of like hook on it. Oops, that one didn't show up. Limison, 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 limison. Just a little accent on there that's underneath the C. Four things are going to happen. And this comes whenever you see an equation in the form of a plus or minus b cosine or b sine of theta, right? And what's nice is the sine and the cosine don't do anything different. They do the same thing. But what you have to look at is the a and the b. If you take the a value, the number that's by itself, and divide it by the b value, the number in front of the trig function, if that number is less than 1, you're going to get a limison with an inner loop. This little kind of circle, and then it goes whoop on the inside. So just to kind of see me draw that in real time, it's going to be something like that. That would be a limison with an inner loop. If you divide a by b and you get 1, meaning a and b are exactly the same, they're the same number. If that happens, you're going to end up with a cardioid limison, which is this kind of like heart shape, right? It's kind of like a little kind of juts in right there. That was a terrible drawing of one, but kind of like that. Little heart. A little bit more rounded on this edge right here. And if you divide a and b and you get a number bigger than 1, but not quite bigger than 2, then you're going to have a dimpled limison, which is kind of like example 1 on the last problems we just did, right? You're going to get a little dimpled limison. Like I said, check example 1 on the last page of notes and you'll see that. And if you divide a by b and you get a number bigger or equal to 2, you get a convex limison, which is kind of like a circle that's really big on this side, but clearly kind of like gets smashed on this side and stops being circular. It's kind of like a circle with a smashed edge on this side, like someone took a hammer and flattened that side. And those are your limisons that you're going to end up with. I don't think you really are going to acknowledge the fact that the b here is negative or positive. It's just saying that you divide a by b. You can see that this is always some value that fits into that, right? I think you're looking at the absolute values when you do those. And coming down here, the rose petals, and I think these are some of the coolest ones. Rose petals are affected by when n is odd versus when n is even. If n is odd, you have exactly n petals. So if there's 1, then you have 1 petal, which actually that's not going to happen. There's no 1 petal roses. If you have 3, you're going to have a 3 petal rose. If you have 5, you're going to have a 5 petal rose. If you have a 7, you're going to have a 7 petal rose, so on with odd numbers. Even numbers cause it to double. So if you have a 2 for your n, you'd end up with 4 petals. If you had a 4 in there, you're going to end up with 8 petals. If you have a 6 in there, you're going to end up with 12 petals. And every time it's even, you keep doubling the number of petals. 8 gives you 16 petals. So you want to be mindful of that. Whatever n is, if it's even, it's the same. If it's odd, you double it. So you can see the first two are my cosines. And I did one in form of even and one in the form of odd. So the first one's the odd one. And you can see it makes a 3-petal rose. What this would be then would be the equation r equals a cosine of 3 theta. If this happens, you get a 3-petal rose, which was example 2 of the last page of notes, if you want to take a look at that again. A just affects how big the petal is. So you can measure the first petal on the polar axis right here. That tells you how long that petal is. If it's even, so this next one would be the equation r equals a cosine of 4 theta. Again, you can see that a is the distance from here on the polar axis, but because the number was even, it causes it to be double petals. So it's an 8-petal rose instead of 4. Over here, I did my signs, and again, I did an even and odd. The first one is a sine of 5 theta. Because it's odd, we got 5 petals. It stays the same. A is going to be the distance across 1 petal. Again, it could be the diagonal distance. The easiest one to look here, though, is the distance going up on theta equals pi over 2, because that's a nice vertical line that you can count. So A is going to be how tall that petal is. Over here with the even one, though, it gets a little bit hard. Here you have r equals a sine of 2 theta. 2 is an even number, so we're going to double it, so it's a 4-petal rose. And you end up with these 4 petals. Now, because it's sine, you see that cosine starts on this polar axis, where sine starts in the middle of the first axis. So whenever it's odd, it's nice because you still end up with one that goes up at some point. Whereas when it's even, you're going to end up with all of them going in the middle of their axes. So A is going to be this diagonal line here, which is kind of tough to find. But that's it. That's all you got to be able to do from this is identifying them. Again, just so we're aware, if you were calling this a name, you would call this a 3-petal rose. We'd call this an 8-petal rose. We'd call these, continuing on, n-petal roses. Whatever number of petals it has is the kind of rose we call it. So n-petal roses when you go to identify those. Like I said, that's it. That's all you got to be able to do for that. I think that's going to make what you've been doing a little bit easier and should help you out. So let me know if you have questions. Bye.